Hello everyone, welcome back to Day One Dev. Today we're going to talk about the model which we're going to create based on handwritten images. So to start with that, let's start with our first data set, then we'll jump into our notebook and we'll talk about that. So please subscribe if you have not subscribed to Day One Dev. Meanwhile, let's go for a data set. Right. So if you see here, I am calling out from the data set from UC Irvine, which is a machine learning repository. They have a lot of data sets here. Uh, Maybe I'll give you a quick walkthrough. I can see a lot of data sets. You can see here almost 677 multiplied by 10. So there are almost 6,000 plus data sets are available. So feel free to explore this part, go to UC Irvine, and you should see here all the data sets. Now let's focus on our data set, which you're going to do here. It's called MNIST. It's a handwritten images. You have all the stuff in 60,000 plus data sets are available. And if you see here, it's called a 70,000. But generally, we use most of the time is a 60,000, which is we use for a training, and 10,000 for for a validation purpose. And most of them are in 28 by 28 grayscale for images. Also, it's called out here. You can see here, they split 60,000 for training and 10,000 for testing as a called out. And this is a pretty good source of data sources, which I rely, especially when I'm training people within machine learning models, right? So let's keeping aside on our data set. Let's jump on our model here. You can see here, I did created most of a notebook, and I'm gonna keep all the stuff in available in my repository. I'll also provide this entire notebook as part of a YouTube video. All right. So let's, you might have seen I started this entire building entire Jupyter notebook, but let's go step by step. As to practice your machine learning, I do always suggest is write your objectives. This is one of a major step if you're not an data science practitioner or a machine learning practitioner. There are a lot of people, they don't document what is the objective and the detailed information. So they start looking at code, which is, yeah, you can do that if you are more towards a developer mindset. But if you are a data science, you need to have your objective and you need to have a valid documentation of what you're doing, everything. So the first step, what I do is I install a library. The required library is required, like for example, Torch Vision, which I'm using it, and I'm using a matplot to display images. And I use this auto time. I'll show you why, what does value it's going to bring in for auto time. This is the one where you have to use this kind of a command. You're loading auto time, and it will give you the time it took to process this code cell. Why this is important? If you're looking at a big picture, how long this code block is going to execute, this is really important when you are looking at your observability and metrics. So performance and all the stuff. I know data science practitioner, they do not care how long it's doing it, but if you are transforming this to a cost, this is important when you're bringing in CUDA, which is a GPUs and all, your provisioning, how long it takes. This number timestamp is going to be easier for you to predict, hey, I'm going to spend this X amount of dollars to train my model, right? That's a big picture. Then following that, following all the standards of imports. I'm keeping all my imports here, most of my imports. And you can see here, I'm loading my data set, and I'm splitting right away my data sets into training data as well as a test data. And I'm using a batch size of a 64. And this is just in a loop where I'm displaying the loader. All right. So now after that, you can see here, I'm just printing out some data sets just for my data types and all to discover myself to understand what kind of is it aligned with all the stuff. And similarly, I'm printing out my unique values, the labels, what kind of a data set I have it. And most of my data set is see here. I have a 0 to 9, which is technically 10 numbers. I have it here, and their size also I'm calling out here. So I have a zeros about 5,923, and number one I have a 6,742, and similarly you can see it's a 9. I have a 5,949. That means the data of a zeros and 1 to 9 are not consistent. They have their own different data sets within the entire 60,000 which I'm using it from my training data. Okay. Now you can see here it took 1.4 milliseconds to print this object. Now this is if you are focused on a machine learning, this block of a code is no value. But if you are more looking at a data science perspective, this has a value. The reason is I list out my data to see how the data has been rendered here. Right? So you can see some of the data which I'm printing here. I think I'm printing 16 images. No, sorry, 20 images I was printing. So you can see here within a 20 images, there are some handwrittens, and I'm printing based on a size of 24 by 24. I think that's a default size, or 28 by 28. I'm using it. Uh, the default size I'm picking up, and I'm printing the images. Now, this is where the model which I'm going to train it. So you can see here, this is a kind of a setting my PyTorch, saying that there's a kind of a CUDA, which is a GPU, and MPS I'm using it, which is a Apple Silicon chip, which is my device right now. I'm running over M3 Apple device, so definitely it falls under MPS. And CPU, if you do not have a mod GPUs or anything, don't worry. Still, this is a text-based NumPy, because you do not have a lot of processing, image processing. So even you don't need any of your GPUs. All right, that's good. Now, going within a neural network, this is if you're a beginner, most of the time you will be using a basic level of a model trainings, where you might be seeing as a skit and all, but I prefer to do a train within a neural networks. If you're beyond, uh, I should say a beginner, then you should be a little bit more towards start with the neural networks. So you can see in my neural networks, I'm using one of our steps, a couple of 3 layers. I'm using it, 3 linear layers. You can see also I'm using ReLU twice. So if I put my neural network, if you're not familiar how the neural network is, just learn about that and do some Google. You can see that it's more like our brain neurons, how they're connected. It's pretty much they are. Right. Now, I'm not going to talk about different models which are used in ReLU or softmax. So I want you to look at it. But you can see here I'm using a sequential. That means my neurons will be triggered sequentially. It's not going to be an kind of a random. Right. So once it's done, I'm doing a flattening all my data, and I'm putting all my size about a 28 by 28 here, all my data sets, and I'm prepping it. So you can see here my MPS, because I'm using MP3 as a set. M3 of an Apple device I'm running on. Now I'm training my data set. I'm using some kind of a learning model. And I'm also, you can see here my entire training model based on this loss and all the stuff, which you don't need to, if you're not familiar with an Y loss function and all. I'll do a separate discussion or separate a model or the video regarding loss function to understand why is a loss function is going to be. Okay, and meanwhile, you can see this defined a batch size of a load. I'm loading it, and I defined my entire payload, and it's so the entire model has been took time for this about pretty close to 1.01 milliseconds for entire this code has been executed, right? So then now I'm doing a test loop. I'm running it to make sure that my data is valid, and which have been trained with the properly everything. So I can see here, my entire this function of a code, it took almost 391 microseconds to execute this block of a code, right? So now the most of our model we are trained. Now I can see here I'm running in multiple epochs. Right now I'm running small epochs So if you are not familiar with what is the term of a epoch, epoch is more like a for loop. If you're an application guy, in data science, we don't use a term as a for loop. We use the term as a epochs. Okay, so don't get confused if you heard this epoch from any data scientist or all these guys. Just visualize that as an for loop. So once done, you're doing a training of your data based on a for loop. You're retraining the data and the loss function. If you're losing your data, then technically at some point, you're going to kill automatically yourself. So if you see here, I did in epochs 1, my accuracy rate is a 95.8 and loss is a pretty much a small 0.13. But in my second iteration, my accuracy is a 98.1. It has been. So that means it did not executed my 10 loops. So it has been stopped at my 2. So because my loss is 0.8. So that means technically it has been not done most of my execution part. So entire this epochs, it took almost 36.7 seconds to complete this job. Now, finally, I'm saving a model. And this is where the interesting part is testing a model. So you see here, I'm using a test data of my model, which is I'm using my test data to test my output. So this is my prediction, providing the test data, and I'm getting an actual output. So now I'm going to show you what I did in my exercise to make it I downloaded some internet images. I can see here 1, 2, 3. Right. So you can see 1, 2, 3. I downloaded these images from internet, and I was trying to call out testing a model with a handwritten image. Right. So it failed here. Image is not defined. Okay. I renamed a variable, so that might be the issue. Okay, no worries. We can do that. Dude, all image sensor, sensor. Okay, okay, I know. Rename the variables to simplify. Okay. So here you can see here my part of a code. I'm reading the images from this folder. Oops. Yeah, image handwritten images, and I'm parsing this image to a text because this has some color. My image, you can see here, number 1, it has some color. So I'm transforming it to grayscale, which is generally, it's going to be easier. I'm resizing it to 28 by 28 because we did here our resized our image when we are predicting it, which, where was that? There you go, image resize, we did it when you're providing it to neural networks, right? So maybe I should have used a variable, but I want to keep this validation testing part outside. Okay, okay. And you can see here, I'm transforming it to my tensor. If you're not familiar what is a tensor is, I want you to go and look at my previous video, which I called out what is a tensor is. So you will understand which is how the tensors are being called out. So once I created tensor and I'm sending it to my NumPy format, I'm converting my tensor torch using NumPy format. And I'm sending it to my model here. You can see here, and I'm predicting the image value, which is coming from my prediction. And so that way I know my file, what has been called out, and it's printing out. So you can see here, I'm got the image, and it's been called out all my 3 images here. All right. So I hope you got this or able to understand. If you have any questions, please post by messages or comments on my video, and I'm happy to solve more of this stuff. And maybe in next videos, I'll show you how to transform this in ML model. All right. Thank you for watching, and I'll see you in the next video. And meanwhile, please subscribe to Day One Dev.